One of the most divisive and probably most argued about menu options in a video game is the camera toggle to invert the Y-axis. I don't know if it's a subconscious rogue fighter pilot fantasy or just years of cranking a tripod head with this doohickey, but I am physically incapable of starting a game without first going into the options menu and inverting the camera. The existence of this menu option, and its polarizing nature, is one that has gauged enough widespread attention that it's actually become the subject of a number of different academic studies. Something as seemingly simple as having the camera look up or down when the player presses a specific input, and the lack of consensus on the matter shows us that as developers, we can create an extreme amount of friction simply by way of how we lay out our inputs along the keyboard or gamepad. It should make sense then that giving the player more freedom over how the gameplay controls are mapped to their input device would offer a more flexible and desirable outcome for the player. If you're lucky, you'll get a selection of a few preset control schemes on a gamepad, or some minor settings around holding a button or toggling it. But time and time again, we see plenty of games with little to no options offering any flexibility for remapping controls to locations that might be more comfortable or less cognitively challenging to the player. Now, there are a plethora of reasons why certain engines or games might choose not to do this. I'm not here to pick that fight today, but in cases where it's purely oversight, I'm here to advocate for implementing support for rebindable controls early, and thankfully, it's not as complex to do in Unity as you might think. So today, we're going to take a look at how we can build a control scheme that can not only be mapped to both keyboard and gamepad and switch between them seamlessly, but also how we can give the player the option to choose from a preset selection of control schemes or fully remap the controls themselves. Hi there, I'm Matt, and welcome to Game Dev Guide. In this episode, we're going to look at how we can use Unity's input system to set up a series of controls and map them to both keys on the keyboard and on the gamepad. We're going to build an interface in UI Toolkit, taking advantage of its binding system to procedurally build an options menu for the controls, allowing the player to view them in the menu. We're then going to look at how we can allow those controls to be swapped with different presets, and also write code that allows individual controls to be remapped by the player to keys or buttons of their own choosing. Finally, we'll also ensure that the custom bindings are saved and loaded between sessions. Before we get started though, I'd like to take a brief moment to thank the sponsor of this video, Odin. If you've never heard of Odin before, they are the creators of Odin Inspector, which is a tool that significantly speeds up your Unity workflow. It allows you to build custom inspectors much more easily by using a combination of their 130 plus built-in attributes to define how you want your inspectors and editors to look, rather than needing to write thousands of lines of custom editor code. Odin have just launched their 4.0 version, and it is the biggest update to the tool since Odin launched 8 years ago. This update includes their brand new Visual Designer, which has a complete drag and drop interface, allowing you to create advanced custom editors in minutes without writing a single line of code. With the new Visual Designer, you can add groups, buttons, attributes, and a variety of other components with a simple click of a button and configure everything within the Visual Designer window. All configurations made through the Visual Designer are stored in separate, human-readable files, keeping all of your custom editors and tooling completely separate from your project's code. Beyond being a huge time saver, it also makes all of your editor tools both very scalable and maintainable. And with the Visual Designer, it now also lets non-programmers safely create and tweak editor tools, freeing up resources for your engineers to work on the parts of the game that matter most. And it's great for rapid prototyping and iterative tool building. So if Odin Inspector and the new Visual Designer workflow sound like your kind of thing, grab it yourself using the link in the description down below, or by scanning the QR code on screen now. Odin's personal license is a one-time purchase, and they offer a completely free and fully featured 3-month trial with no strings attached. Thanks so much to Odin for sponsoring the video. Now let's jump into rebinding some controls, shall we? So as you can see, I have a little 2D asteroids-like game that I'm building here. Currently, the ship is just a vessel observing space and getting obliterated by nearby rocks as they make their way through the void. So I'd like to actually turn this into a game and give the ship a fighting chance. To do that, we'll need to set up some input actions and map them to our spaceship controller, allowing the player to fly around. I built this project using Unity's 2D URP template, which as you can see comes with a set of predefined input actions, so we'll use that as our starting point. We'll rename this to something simple like base actions. We'll go in and remove most of these actions here, keeping move, attack, and rename this one to boost. And then we'll save the asset. We can add a couple of additional actions later, but these should do for now. If we take a look here, we can see how some of our keys are initially mapped. Our move is mapped to the left stick on the gamepad and WASD on our keyboard. Our attack is mapped to the left mouse button or enter on the keyboard. Enter is a little awkward, so let's switch this to the space key. And for our boost, shift is fine on the keyboard, but on our gamepad this should probably be one of the triggers. So let's go for the right trigger. And actually, let's swap fire on the gamepad to south button instead of west. This is a good initial set of controls. Let's now get our ship controller hooked up to these inputs. Let's add a player input component to our ship. As you can see, this will auto-assign our actions, and we get this little warning here, so let's go into our project settings and remove them globally. Let's also set our default scheme to keyboard and mouse, and set the default map to player. As this is set to send messages, we can use methods on our controller to capture these inputs. So we'll add a method for each into our ship controller. And as you can see, we'll now receive these input events when our keyboard or mouse buttons are pressed. So let's go ahead and set these up. We'll grab the input from our move action and split them into 2 floats. I want the turning to be pretty deterministic, so we'll keep it as a simple fixed value and handle the turning from our update loop. I want the ship to react to physics objects in the scene, but I don't want it to be overwhelming, so we'll make sure that when we turn, we scale down any angular velocity that we might have gained. Generally, this is just a personal preference thing, as I'm not a big fan of relying on physics for handling rotation of the player. I much prefer turning to feel responsive, so that's why we're directly controlling the rotation here. For the forward movement, we'll add its own method and use relative force to add some velocity in whichever direction our object is currently facing. If the player uses the down input, we'll essentially have this act as a brake by scaling down the linear velocity relative to their input until they come to a halt. As you can see, this now gives us quite a nice physics controller for our ship that's floaty enough for a space scene, but responsive enough to be able to navigate around the hazards easily. Now let's make use of our shoot mechanic. Due to the way the actions work, when they're set as buttons, they only fire a single event when the button is down, but we don't want to keep having to press the space key, so we'll want to update our fire action from a button to a value so that we can detect it being unpressed. Now, in our onAttack method, we can check if the value is above 0 or not and assign a boolean to tell the ship to fire. At the bottom of our update, we can add a method to spawn a bullet if we're firing. In here, we'll spawn a new bullet, aligning it with the transform and direction of our ship, spawning it slightly in front. We'll also give the action a slight cooldown as the button is held down, so we're not spawning a bullet every single frame. The bullet itself is pretty straightforward, it's just a small sprite with a capsule collider and a rigid body. When the bullet spawns, we just add a continuous velocity in the direction it's facing, and destroy it if it hits anything, or if it's around for longer than about 3 seconds. And with that, our game is now coming together. We can fly around and shoot the asteroids to gradually destroy them. As you can see, I've also added a VFX element to spawn whenever the bullet hits something, and some effects for when our asteroids explode. Finally, let's just add our boost mechanic. Like we did before, we'll start by setting our boost key from a button to a value. This way we can detect whether or not the boost key is pressed or released, and use that to determine if we're boosting. We can then use this value to start and stop some looping VFX that we place on our ship. Next, we'll add a method to handle our boosting. I want our boost to feel like a sudden burst of power, so we'll define a new value for a maximum boost velocity, and in our boost method, we'll check to see if we're boosting and whether we've hit the cap or not. Then we'll just add a chunk of forward force whenever the boost button is down. If it isn't, we'll quickly cut our speed down to the maximum velocity. We'll probably want to balance our values on the ship a little so that the base max velocity is a little lower and make our boost feel more meaningful. And now we can be a bit more acrobatic and boost our little ship around our environment. I think it would be really nice for the player to look at the controls that are available to them through a UI menu, so let's go ahead and set one up. First, we'll want to add a new action for the player to access a menu. We'll go into our actions asset and add a new action called menu. This one is fine to leave the action type as button, as we do only want to know when the button is pressed. In here, we'll add a binding for the escape key on our keyboard, and then one for the select key on our gamepad. We'll start by creating a new UI document in our scene, and then let's open up UI Builder and create a new UXML file and a new USS file called menu. In here, we'll add a new root visual element and assign a basic transparent black background to it. We'll name this panel. I like having all of my style info tied up into selectors rather than inline on the UXML, so we'll add a new style called panel background and choose extract inline styles to new class. Then we'll add another visual element which we'll call window. This will be where most of our content for our menu is going to go, so let's add an opaque grey background and let's also give it a bit of a margin so we can see some of our game in the back. And then we'll extract this into a selector as well. Let's also turn on this class list view in our hierarchy here. I want to be able to show and hide the UI document elements, so let's make a new selector called hidden that we'll be able to apply to various elements throughout our window, and then we'll apply it to our root panel element here. Then let's assign our new menu to our UI document, and then we'll make a script on our UI to act as our manager. This will be a singleton instance that will call from our ship when the menu button is pressed. Right now, all of our input events are being controlled from our player controller directly, but in a larger project where multiple systems will need to react to input events, it's probably better to have a manager class listening to the player input component, and then have that class send messages to both the player controller and UI and whatever other systems need to know about input. For this demo though, which we can essentially treat as a prototype, it's fine to be a little bit messy. It's just something to keep in mind as scope grows. Anyway, in here, we'll assign our UI document and grab our panel from the root element. We'll have a method called onMenuButton that our ship can call, and use a boolean to determine if the menu is open or not, and then 2 corresponding methods to add or remove the hidden class on the menu accordingly. We'll also set the timescale so the game doesn't continue playing while the window is open. And with that, we now have a menu that we can pull up in our game. One of the most useful features of UI Toolkit is how we can bind elements to specific pieces of data and have them populate themselves. This menu is going to act as the way our player can view and switch up the controls, so let's make an element that can display an action and its mappings and have each element bind itself to our actions. We'll create a simple row element with 3 sub-elements, an element for the name of the control, an element for the keyboard control name, and one for the gamepad control name. I've also just set up some basic selectors to style these out a little bit. Now we can tell our element to assign itself to one of our input actions by setting the data source type. Let's select our entry here and choose type and then select type. Then let's grab the input action type. Next, we'll get our control name label to display the name of our control. So let's go over here and click these 3 dots next to the text control in the inspector and choose Add Binding. In the menu, we can see that it has our parent data source assigned, so we can simply grab the name of our input action. To quickly demonstrate this, let's build a little test method in our UI manager. When the menu opens, we'll call our test function and grab our visual element. We'll then grab the initial action in our asset and set it as the data source in our element. As you can see, when we open our menu, the name of our action now appears in the label of our visual element. So this is great for our first label as it uses the name on our input action, but for our second and third, we're going to need to dive into the bindings themselves in order to be able to display their names. Now, I could write a bunch of custom code and bind the input binding type to these, but I really would just like to be able to assign the data source to our root element here. So instead, let's take a look at writing a custom binding for these sub-elements. Custom bindings are one of my new favorite things about UI Toolkit, as they open up a ton of versatility for different ways we may need to represent data. To start, and to simplify things a little bit, let's clean up our input actions and assign them in order of device. So the first entry will always be our keyboard option, and the second one will always be our gamepad. Then we'll create a new C# script called Custom Input Display Binding. This is a partial class and extends from the Custom Binding class. We'll also want to make sure we include the UXML object attribute. Here we'll add an enum for our 2 device types, and add the UXML attribute so it shows up in the UI builder. In the constructor, we'll tell our binding to update when the data source has changed, and we'll override the onDataSourceChanged method. In here, we'll grab the target element from the context, and we'll try to get the data source from it. This will usually be null, so we'll want to grab the closest data source from a parent using the getHierarchicalDataSourceContext method. In our example, this method will grab the data source on our row element, which will be a few parent objects above our label where the script will run. Then we'll just make sure that there's actually a data source assigned, and check that it's an input action. Here we'll try and find the input binding struct that's defined for our specific device we care about. This method essentially just uses the group info on the bindings to figure that out. Then we'll either display the binding name or the display string name depending on our circumstance. And finally we'll use the trySetGlobalValue method to assign our value to our current element, which in this case will be our label. With that done, we can now head into the UI builder and assign our new custom binding logic. We select our keyboard label, and then in the binding window, our new custom binder should show up in the dropdown here. Then we'll add this as our binding. For our gamepad label, we'll do the same thing, but we'll switch the device over from keyboard to gamepad. Now, both of our labels are using our custom binder to find their correct information from the single data source we assign on the base element. Which means that with essentially one line of code in our UI script, we're able to populate our entire row with the information we need. Next then, all we have to do is populate our window here with all of our available actions. Let's make a template out of our row element here, and then let's add a new scroll view into our layout where we can list out all of our controls. Then in our script, let's get a reference to our control element template and assign it in the inspector. We'll then rename our test method to display controls, and in here, we'll grab a reference to the scroll view we created earlier, making sure to clear its contents. We'll grab our reference to the main action map we care about, and then in a for each loop, we'll grab each action in the map. we'll clone the tree of our template directly into the content container of our scroll view, and then fetch this entry using the element at method on the container. I like to clone our templates this way because it removes the unnecessary container that gets added to the hierarchy if we just clone the tree normally. Anyway, as you see, we now have all of the entries in our action map and they each show up in our menu here. If we add a new entry into our action map, our menu automatically updates and shows the new bindings for the action. With just a few lines of code, we now have a fully automated actions list. When using a gamepad, it's pretty common to provide the player with predefined layouts that they can choose from, so why don't we take a look at how we might be able to do that here and provide a way for the player to change their overall control scheme from some presets. One of the easiest ways to do this is to make a new action map for our alternate control scheme. So let's head into our actions asset, and in here, let's rename this to player default, and then let's duplicate this map and name it player alternate. We'll then go ahead and change up some of the control mappings, and let's also make sure our player input controller is assigned to the renamed map. In our menu, let's go ahead and add a new toggle button group. We'll leave this empty for now as we'll want our various maps to auto-populate in here, but this will be where the buttons go to allow our player to switch between the different control schemes. Now let's refactor our method to support displaying different action maps. We'll grab a reference to our toggle button group, then we'll search our action maps for any containing player in the name. And for each of these, we'll add a new button to the group. When our button is clicked, we'll display the controls for the given maps like we did earlier. Now, when our player opens the menu, we get two different control schemes that can be displayed and toggled between. Finally then, let's add a callback to the menu that invokes when the player switches their scheme. And in our ship controller, we'll grab a reference to the player input component and update the current mapping based on this callback. So now we have a way to switch between preset maps. Let's look at going one step further though and give the player the ability to fully rebind their controls. Let's add a new button to our control template here. Then in our menu script, when we add a new element, let's grab a reference to its button and add a callback to trigger our remapping event. In this method, we'll create two rebinding operations, one for the keyboard and one for the gamepad. This interactive rebind would normally just default to overriding every binding type, so we need to be exclusive and tell it which one to override depending on our input. As we've organized our input asset to always have the keyboard input first and gamepad second, we can set our target binding index on our keyboard operation to 0, and on our gamepad operation we'll set the index to 1. That way each operation will assign the correct path to the correct input. In our complete method, we'll cancel both operations and redraw the control layout. As you can see, we can now go in and fully rebind each of our control entries using both of our input types. As a final step, let's just make sure that these rebindings stick by saving them out to a file and reloading them. Let's create a new method here that grabs the overrides as JSON from our asset, then let's create a directory in our application's data folder and store our JSON text there. Let's then add a method to load our overrides when the menu first initializes. In here, we'll simply try and find the controls file, and if it exists, we'll load them as overrides on our asset. With that, we now have a fully automated way for the player to remap and rebind controls in our game. And that's about it for today's video. I'm sure there are plenty of things to dive into further that your project might demand, but hopefully this has given you a good jumping off point for adding support for custom control bindings into your game. I'm always keen to hear if you found the video helpful and how you might use this information in your own project, so if you've enjoyed the video, be sure to hit the like button and let me know your thoughts in the comments down below. Thanks once again to Odin for sponsoring this video. Be sure to check out the link in the description and use code GameDevGuide20 at checkout to get 20% off their personal license. If you're new to the channel, please do consider hitting that subscribe button as you'll be notified when new videos go live. Alternatively, if you'd like to see more from me first, consider checking out one of the videos on screen now. As always, thank you very much for watching, and I will see you again next time.